section 2.2. In section 2.2, we're talking about exponential functions and models. And our goal here is to learn about exponential functions because they can give better models in applications like population growth, radioactive decay, the growth or depreciation of financial investments, and many other phenomena. Okay? But in order for us to be successful with learning about exponential functions, you need to make sure you remember the following. The laws of exponents, okay? If a and b are positive and x and y are real numbers, then a to the x times a to the y is equal to a raised to the x plus y. You have the same base, you add the exponents. A to the x divided by a to the y is equal to a to the x minus y. 1 over a to the x can be rewritten as a raised to the negative x. A to the 0 is equal to 1 provided that a is not equal to 0. Provided that a is not equal to 0. Okay, and then we have a raised to the x, that raised to the y is equal to a to the xy. AB to the x is equal to a to the x times b to the x. And a divided by b to the x is equal to a to the x divided by b to the x. Okay, so those are your laws of exponents. Let's start out with the definition on page 2. On page 2, let me zoom in a little bit. Okay, an exponential function has the form f of x equals capital A times b to the x. The capital A, it doesn't matter which variable you use here, where a and b are constants with a not equal to 0 and b is positive and not equal to 1. Okay, this is the form for an exponential function. Note, b is called the base of the exponential function. B is called your base of the exponential function. So now let's look at the graph of two specific exponential functions. The first one, let's graph the function 2y equals 2 to the x, or f of x equals 2 to the x. Okay, now do you want to do an XY chart for this? Or do you want to see the graph? You have to talk. So if you set up an XY chart, when x is -1, we have y is 2 raised to the -1. But by our rules on the previous page, that's equal to what? What is that equal to? No? 1 over 2. Very good. It's equal to 1 over 2. We're using the rule that said that 1 over a to the x is the same thing as a to the negative x, not 2, thinking of the problem we're working on. Okay, so that's what we're using there. Okay, when x is 0, y is 2 to the 0, which is what? 1. Good. So 2 points we can plot is -1, 1/2. That's 1 point. The next point we can plot when x is 0, we get 1. So we can plot that point. What about 1? When x is 1, what's y? 2. So we can plot, good by the way, so you get 1, 2. And you can see the pattern. Will this function ever touch the x-axis? No, it won't. It'll get close to it, but it won't touch it. Okay, so our graph looks like that. That's the graph of y equals 2 to the x. Okay? Okay? All right, so that's an example when our base b is greater than 1. But now, what happens to the graph of an exponential function when b is strictly greater than 0 but less than 1? Let's take or consider the exponential function y equals 1/2 raised to the x. Okay? You can do the same thing with an XY chart. Would you like a minute to try it? Okay. What is the shape of this graph? So we saw in this one, it was increasing. Is it increasing in the one over here? No. What is it doing? Decreasing. So did you use the same x values? Yes or no? Yes. Okay, so for x, you try -1, 0, and 1. What did you get for y when x is -1? 2, good. 0, 1, 1, 1/2, very good. So you plot -1, go up 2, then you had 0, 1, and then you had 1, 1/2. Does it ever cross the x-axis? No, very good. Very good. So that's your graph. That's your graph. Notice that it's decreasing here. So what you should notice here is that when b is greater than 1, your exponential graph has the y-intercept 0, 1, and it's increasing. Whenever b is between 0 and 1, your graph is what? Decreasing. Good. Your graph is decreasing. Your y-intercept is what? What's your y-intercept? 1 or 0, 1. Okay, very good. Okay, so now let's look at the next example. I want us to graph f of x equals 4 raised to the negative x. 4 raised to the negative x, and I want us to use the fact that x is between -3 and 3. Would you like to do this together, or would you like to try it? Together? Okay, so you can make a table. So your x values, your f of x values, you can do it vertically if you like. I'm just doing this for space. And then you have -3, -2, -1, 0, 1, 2, and 3. Okay, when x is -3, we have 4 raised to the negative times -3, which is equal to 4 cubed. 4 cubed is what? What's 4 cubed? 64. Okay, you want to do it together, you have to respond. Okay, good. 64. So when x is -2, you have 4 raised to the negative times -2, gives you 4 squared, which is what? 16. When x is -1, what's f of x? 4. Good. When x is 0, what's f of x? 1. Good. When x is 1, what is f of x? 1/4. Good. When x is 2, 1/16. Good. And when x is 3? 1/64. Very good. Okay? So then you go in and you plot the points. Whenever you plot the points, then you're going to end up with the shape of your graph looking like so. What questions do you have? Okay, so we graphed 4 raised to the negative x. Now, let's find an equation for an exponential function that passes through the points 2, -4 and 4, -16. we want to find an equation for an exponential function that passes through 2, -4 and 4, -16. Am I moving too quickly? Okay, so for this problem, we have -4 is equal to AB squared. Where in the world did that come from? Remember, your general form for exponential function is f of x equals AB to the x, right? So recall that f of x can be written as AB to the x. And f of x also represents what variable? Y, right? So what we're doing is we're choosing the y coordinate here. Okay? Similarly, we can say A, B. Note that, where did the 2 come from? The x, right? The 2 came from the x. So that's where this 2 came from. So tell me, what is the other equation I can write down based on 4, -16? Say it loud. -16. AB to the 4th. Good. So we have these two equations. What we want to do is we want to find an equation for an exponential function that passes through those 2 points. So what we can do is we can divide the second equation by the first to get -16 over -4 equals AB to the 4th divided by AB squared. -16 over -4 is what? 4, good. It's a huge 4. We'll go with it though. What happens with the A's? They cancel out, good. And what is B to the 4th divided by B squared? B squared. So we get B squared is equal to 4. Or in other words, B is equal to what? 2. Technically, you would get plus or minus 2, right? But can B be negative? No, good. So B is equal to 2. Now we're not done, because what we did so far was we found our base. But now the problem says find an equation for an exponential function. So we have to find A as well, okay? But now that we found B, we can substitute that into, let me call this smiley face. We'll call that smiley face, that equation. We can substitute. So substituting into smiley face, we get -4 is equal to A times 2 squared, because that's our B. So that means -4, I'm going to go up here. That means -4 is equal to 4A, or A is equal to what? -1, very good. So what does that mean f of x is equal to for us? Talk a little bit louder. Very good. F of x is equal to -2 raised to the x. Very good. Yes. So we have our function is f of x equals -2 to the x. Okay? Now, compute the missing values for r of x equals 2 raised to the -x plus 1 in the table and graph r of x. Would you like a minute to try it? Okay, go for it. When x is -3, what's r of x? 9, very good. When x is -2? 5, negative 1, 3, 0, 1, 3 over 2, good. 2, 5 over 4, good. And 3, 9 over 8, good. Does anyone have questions about that?
Yeah, after 0.
After 0? Okay. So when x is equal to 1, r of 1 is equal to 2 raised to the negative 1. And you're not the only one with the question, so thanks for asking.
Yeah.
2 to the negative 1 plus 1. 2 to the negative 1 is the same thing as 1/2. So that's 1/2 plus 1, which is the same thing as 1/2 plus 2 over 2, which is 3 over 2.
Okay, thank you.
You're welcome. Do we need to do it when x is 2 and 3, or are you good with that?
No, I know.
Okay. Does that make sense? Okay. So, my question to you is, whenever we graph this, what is your x-axis acting as? Or what's your horizontal asymptote in this case? So before, when we sketched the graph of 2 to the, what did we graph? 1/2 to the x? Okay? Whenever we graphed that, we saw that the graph couldn't go past the x-axis, right? So the x-axis was our horizontal asymptote. What? Sorry, my bad. What is that? Hold on. Y equals 1. Very good. Y equals 1. So this plus 1 says take the graph of 2 to the negative x and shift it up 1. So notice that your y-intercept becomes 0, 2. It became 0, 2. Okay. And then you can plot your other points. And you'll get that graph. What questions do you have? Okay, so now we are experts at graphing exponential functions, right? We're going to go with that? Okay, make sure you work through your homework, and if you have questions, let me know. Okay? Let's talk about the following. A quantity y experiences exponential growth. Bless you. If y is equal to ab to the t with b greater than 1. So now we're in the case of that very first graph that we drew, where your graph is doing what? Is it increasing or decreasing? Increasing, good. A quantity y experiences, guess what we're going to say here, if y is equal to ab to the t, where b is between 0 and 1. Exponential decay, good. Okay, so now let's look at an example here. We have a bacteria culture, starts with 1,000 bacteria. 2 hours later, there are 1,500 bacteria. Find an exponential model for the size of the culture as a function of time t in hours, and use the model to predict how many bacteria there will be after 2 days. Okay, so we first have to remember that our general form is y equals ab to the t. Okay, so if y represents the size of the culture at time t, then y is equal to ab to the t. A is our initial size. What is that? 1,000, very good. So that's 1,000. And then y equals 1,500 when t is equal to what? Good, when t is equal to 2. Okay? So all of that to say the following. We can now set our problem up to say that 1,500, because that's our y, would be equal to 1,000 b raised to what power? Squared. Good, because that's whenever t is equal to 2. Whenever, or y is equal to 1,500 whenever t is equal to 2. Okay? Now we can solve for b. So 1,500 divided by 1,000 is equal to b squared. Then we take the square root of both sides. So the square root of 1,500 divided by 1,000 is what? 1 point what? 5, good. The square root of 1.5 would then be b. Technically we would have plus or minus, but will we have a minus here? No, we won't, okay? So we can just say b is equal to the square root of 1.5, or we can write that as b is equal to 1.5 raised to the 1/2. That's another way of writing that. So, an aside, just to remind you, because I see some puzzled looks, the square root of x, notice that the exponent on x is 1, the index here is 2, so we can write the square root of x as x raised to the 1/2, okay? That's how we're able to rewrite it, okay? So we can say the following. Hence, we can say y is equal to 1,000 times, we know b now, so substitute in b. So it's 1.5 raised to the 1/2, all of that raised to the t. Or in other words, we can write that as 1,000 times 1.5 raised to the t over 2. Okay? Now, are we done with the problem? Yes? No? No. What do we need to find? Talk louder. How much bacteria will there be after 2 days? So, our time is in terms of what? Hours. So 2 days later is the equivalent of what?
40.
Good. So 2 days later is 48 hours. So tell me what to do here.
48 for t.
Good. Plug in 48 for t into what?
1,000, and then you times 1.5, and then you get the t, which is 48 divided by 2.
Very good. And that will give us our y. So when you enter that into your calculators, you get that's approximately 16,800,000 bacteria. It's a lot. What questions do you have? Okay, all right, so now let's talk about the number E and continuous compounding. Let's talk about the number E and continuous compounding. So the number E, notice that as M if we consider 1, the quantity 1 plus 1 divided by m raised to the m, as m gets larger and larger, so whenever we plug in 100, for example, we'll get a number. But if we plug in 1,000, we'll get another number. But it's going to, those numbers are going to approach the number e, which is 2.718,218,28459, and it continues, okay? Am I going to ask you to remember all of this? Absolutely not. This is just to introduce that number to you, okay? So, if P dollars is invested at an annual rate R, which is compounded continuously, which it means you're always compounding it, okay? Then the accumulated amount after T years is given by the equation A of T equals P times E raised to the RT. R is your rate, T is your what? Time in years, and then P is your what? Your initial amount you invest. Good. Okay? So, now what we're going to do is we're going to look at a couple of examples. Okay? Given F of T is the value after T years of a $2,000 investment, earning 5.3% interest compounded continuously, find F of T. What did I give you here? P. What's P? Good. What else did I give you? What's R? What is it? 0.053. Because you're talking about the rate, you need to convert that percentage. Okay? So 0.053. Good. And what can you do from here? Good. So F of T is equal to what?
2,000 raised to 0.053 times.
Good. That's it. What questions do you have? You will definitely need to remember the formula here. Again, make sure if you need to use your cell phones, feel free to go in the hallway for that. Okay. Okay. Given F of T is the value after T years of a $10,000 investment, depreciating continuously at an annual rate of 60%, find F of T. Would you like a minute to try it?
Yes.
Okay, go for it. All right, so what are you given? P, well, let's write it. P is equal to 10,000. What else are you given? R, what's R? 0.6. Negative 0.6. Why is it negative 0.6? Say it again. Depreciating. Good. So negative 0.6. And what can we do from here? Okay, so we have F of T is equal to what? Negative 0.6 T. You got it. Good. What questions do you have? If you have questions, ask. Okay? Go. Do you need me to go back? I see some people still writing. You need me to go back? There. Okay, so our last example here, and I see some working on it already. You have flybynightsavings.com is offering a savings account that pays 31% interest compounded continuously. How much interest would a deposit of $2,000 earn over 10 years? You want to go ahead and try it? Okay. What's our formula? What do we start out with? What's the general form? Go ahead, talk louder.
2,000 raised to the 0.31 times 10.
Times 10, good. So that would give us our A? Yes, good. Okay, so A is equal to P is 2,000, E to the R is 0.31, T is 10. Okay, you enter that into your calculators, what do you get?
44,396.
Talk a little louder.
44,396.
396.
Or 5.9.
Say it again.
6. Well, it rounds up.
Okay. All right. Now, is this it? No, it's not. Why? That's right. You have to subtract your $2,000, which was your initial deposit. Good. So, how much would we earn?
$42,396.
Good. We would earn 42,396. That's if you're rounding up. But if you're exact, you will get 42,395.90. Okay? Good. What questions do you have? Okay.